Good day, everybody. My name is Philip Wanicek, and today I will show you how to issue a PV GreenCard. But before we start with the actual completing of a PV GreenCard, I want to show you this document, which is the basis for the PV GreenCard in terms of standards and regulations that we applied. So as a background, the PV GreenCard system when developed wasn't based on just remote ideas, but on a number of standards and regulations applying to PV systems. So down here you can see that there are solar PV specific standards. I won't go through them in detail, it doesn't really matter. Installation, grid connection, there's a lot on grid connection obviously, and also other standards and guidelines and acts, as well as civil discipline standards. So as I said, these form the basis for the quality program PV GreenCard. And so whenever we have certain requirements in the PV GreenCard form, they don't come because we like them so much, but because there are standards and regulations requiring those. This is just as a background. So now we will switch to the actual PV GreenCard system. So here you see the start or front page. Once you registered as a PV GreenCard installer, you will be able to log into the system and you will see this page. You can make numerous changes from the company side. You can add new installers, check your payments and so on. But the relevant part for us today is the PV GreenCards in general. To make this process today a bit more streamlined, I have already pre-populated a GreenCard. So I'm going to open the existing GreenCards and then you can see, yes, there is one as draft here. And I click on Edit to get into the actual form. This can take a couple of seconds, but here we are. So as you can see, there are numerous questions asked, and some of them have a little star in the beginning. Those are you have to either click or fill out, and then there are others that are voluntary. So of course, you have to define what type of system it is. You have to give additional information on the type of system, so whether it is rooftop, ground-mounted, facade, or so on. For now, we are going with a rooftop system, and I said it is a hybrid system, so we have a battery in place as well. You are required to mention the installed capacity, and here's already one thing that we discovered that we might want to change, because you can only set whole numbers, even though especially for smaller systems it might make sense to have a 3.5 kilowatt system, for example. So this is one of the issues that we will have to address once we revamp the system. You have to upload a picture. So again, I did that, and of course you have to set the alignment or the orientation of the system. So in this case, the PV module is facing directly north at a tilt angle of 15 degrees. This is actually done quite nicely here. So you have this little shift lever thingy with which you can set the tilt angle. In case your system has multiple orientations or inclinations, you would click here and then would be later asked to set the other orientations. As I said earlier, this particular system has a backup battery, so I clicked yes, otherwise you would click no. In this part here, you are asked to set some general information on the premises that the system operates at. So the annual electricity consumption, as well as the assumed own consumption. The assumed own consumption, I admit, might be a bit difficult, especially if you don't run a yield simulation in advance and you don't know what the customer's demand is and the demand curve of the customer. But since this is a residential system, I estimated something around 35%. If it was a commercial or industrial system, it would probably go up to 100%. And you are required to say the estimated PV yield. I set 1700 kilowatt hours per kilowatt peak. So this is not the total demand, but the demand, not the total generation, but the generation per kilowatt peak. It is a number that usually comes out of simulation software, and we will get to that in the last part of this form. I said that me personally, I'm the owner of the system, so I have all my details in here. We don't have to go through that in detail, but this is something that you simply will have to fill so that yeah, it is identified properly. In case the owner-operator's address is not the same as the PV system, in this section you can set a separate address if the two deviate. Next up is the selection of the installer. Depending on how many installers you have added to the system, there's a drop-down menu here, and then you can choose. I stay with this name. This, of course, is a fake account, so don't mind the names. It's Subvia's own fake account. It would require then here to put in the company's address. I won't do that because it doesn't really matter for the process right now. But of course, you as an installer would be required to do that. Then there's a section that is grayed out with the actual PV GreenCard data, so the GreenCard number and the customer approval code once it is approved. This is something that you don't, that you cannot change and are not required to change. This is something that the system generates automatically. What you are required to do is the DOL compliance. So you have to click here that that a certificate of compliance has been issued, and you have to state the electrician registration number and the COC number. So again, these are fake numbers here, but if you should one day issue a real PV GreenCard, then of course the actual numbers would have to be filled in here. And you would have to say in the end, the one who filled and checked and approved the document will have to state his name for reference. So in case the installer, the PV GreenCard certified installer, is not the person who filled this document, then you would put the name of the person who did fill in the document in here. And once that is done, you can go to the next slide. And as you can see, I have only 80% here because I didn't fill in the address of the company, so it's not complete. I wouldn't be able to submit the form to the customer as it is right now, but that doesn't matter for the purpose of presenting this now. The next part is the actual PV modules. So you have to state how many module types you are using. If it is more than one, please state here. And then you are asked for each of the different module types or module sections, as it is called here, to state the manufacturer, to state the module type. Also, please use the exact type. I know that often on the datasheet it says something, but then you have several wattage classes under one name, and so please also add the wattage class so that it is clearly identifiable as this specific module. And then again, you have to state the installed capacity, because if it was several module sections, then the sum of those would form the overall capacity. So that's why we ask this several times. Next up, you have to state, or have to just confirm that the modules are adhering to their material-specific certifications. So if it is a crystalline module, it has to be eligible for a PV GreenCard. It has to have a type approval according to IEC 61215. If it was a thin film module, the IEC 61646 would apply, but I said it is a crystalline module now, so we stay with that. And in addition, you are required to submit the serial numbers to the clients. So either a flash list or a packing list, or if you don't have either, then you simply will have to go through all the modules and note the serial numbers to submit them to the client so that he really knows which specific modules he has. In case the modules or the PV system is installed close to the shoreline, so less than 3 kilometers, the PV GreenCard recommends that the systems are or the modules are certified according to IEC 61701, which is a test that looks specifically at salt fog. So with a more humid, more salty air close to the shorelines, this could cause corrosion, and that's why we recommend that. The same applies to systems that are built on feedstock or feedstock stalls mainly, that usually have a higher ammonia concentration in their surrounding, and ammonia can also affect the modules, and that's why we recommend that the modules are certified according to a standard that looks specifically at ammonia. Should there be more than one module type or more than one module section, you would then here in the next section be asked to do it for the second one, basically the same information again, just a different PV module type. And if there's more than 2, then there's a free text box down here where you can list the relevant information for any other number of module types. The system basically repeats itself for the different components. So the next one would be inverters. Again, you are asked how many different inverter types are used. I chose one again because it's a small system. In this particular case, it's a Victron Energy inverter. Again, the proper name, Multigrid 48-3000, and the serial number. Again, you are asked to tick that the relevant standards are adhered to. So for inverters, that is certified according to NRS 097-2-1, which is looking at the grid interconnection interface of inverters specifically in South Africa. And this is a definite requirement, not only with the PV GreenCard, but also with most of the municipalities who have systems in place for grid-connected PV systems. Outdoor installation, if it is, then please click. And also, if it is an outdoor installation, please click, or please make sure that the inverter has IP54 protective class or higher. And in the end, you also have to state and of course also make sure that the inverter is approved by the grid company or municipality and listed with the necessary certificates. If there were several inverters, then again the information for the second inverter, and in a free text box down here for an additional number of plus inverters could be mentioned. The next section is in regard to mounting systems. So again, the mounting system manufacturer is asked the name of the system. I know there aren't always specific names of the systems, but in that case, at least list some of the components here. Also, you are asked to specify the mounting location, so flat roof, slope roof, facade, ground mounted, and the mounting design, roof integrated, roof parallel, elevated, fixed, or tracking. As I said earlier, we have a roof parallel system on a sloped roof in this particular case, and it is attached to the roof itself via hanger bolt, and that's what I stated down here when you are asked for the fastening system. In case you don't have a screwed-in fastening system, but a ballasted system, so this is something that happens on flat roofs, for example, where you just have plastic troughs, for example, that are just filled with sand or other ballast to keep the modules in place, then we recommend to have an expert calculate the static friction coefficient, and to just make sure that those systems don't fly away during heavy wind situations, especially in the infancy of the PV industry in the early 2000s. This is something that we've seen several times, and of course this is something that we don't want to see repeatedly. In case there are roof hooks applied, which usually is the case with tiled roofs, then you can voluntarily state the product name of the roof hook, and also the specific or the installation details for the roof hook. However, what you are again required to do is to state that all relevant requirements pertaining to building authority regulations and technical building specifications have been met, and you are asked to specify. As you can see, I haven't specified them here. As you might have heard, I'm not South African, so I don't know all the building authority regulations in the country, but I can only recommend you that if you also don't know them, consult a specialist who does, because in case something happens with the system, in case it flies off, falls on the head of someone else, this might become a serious legal issue if you did not adhere to all regulations and standards and building specifications. So that's why if it is not within your experience or capacity to say whether you did, please consult an expert to avoid legal trouble here. And finally, you are also required to tick that the material itself and combinations have been chosen in a way that the risk of corrosion is minimized. So this is something that, of course, we require. Now the whole thing again repeats more or less with cables and power lines. So I will only go through it once and not through all the different steps. But again, you are asked to state the manufacturer and the type and product code of the cable. Please be specific here so that the owner of the system or the operator who in the end has to approve your PV GreenCard is really able to do that. And also you are asked to put the cross section. I give you a good example for the specific type name. So the SolarFlex X PV1F is a typical solar cable, and the experience that we made with PV GreenCard is that most people fill in that part correctly. However, with the AC cable, we have seen that it usually states just standard AC cable, even though every cable has a specific product code or name. And this is one, for example, for a typical AC 3-wire 2.5 square millimeter cable. So it's not difficult to do it. So please just do it. Then this is a good example for improvements within the system, because as you can see here, I stated 3 square millimeters, even though up here we can clearly see that it is a 2.5 square millimeter cable. So why did I do that? I will show you. If I type 2.5, it will tell me, please enter a valid whole number. So of course decimals would be required here, but the system currently doesn't allow it. But this is something that we have identified already, and we will change it. Also, you are asked to state the average nominal losses, or that the average nominal losses are below 1%, and if they are not, and there might be reasons for that, please state the exact number. And as with all the cable sections, you are also required to state that the current carrying capacity according to laying building ambient temperature was considered. So this is something that as an electrician you should be more than aware of. And that's the next section, so we can just go to the next page where we come to the actual array design. Here you can see a grayed out part again, so that is taken from the very first page, but then you are asked to state the number of arrays. So in my case it is only one, but if you have several, please state here again, and then further down you will have the opportunity to give the specific details of each of the arrays. So, but in our case, sub-array 1, we will just have to repeat the orientation, so pure north, and the module pitch 15 degrees. And then we come to the point, to the electrical part of the array. So we are asked to put, to state the number of modules in series, or per string. And that in this particular case is 3, which is not usual, but it is because we have a battery backup system. So we have a lower voltage and have shorter strings, and at the same time more modules in parallel, so a more total number of strings. That's also why the system voltage of this particular system is lower. So usually you probably will find something like 12 to 15 modules in series, and system voltages in the range of 700-800 volts. And in this case, then it's only it is also 4 strings, even though with a 3 kilowatt system it could well be 1 string if you would have higher system voltages. And you're also required to put the operating current in here. If the person who fills in this document or the details into this document is not the technical person who planned and installed the system, this of course might all be pretty difficult. So that's why if an admin person or a PA fills in this document, it is really necessary that the technical person doing the planning and the installation provides all the data to that person. Otherwise, there is no chance that non-technical person will be able to fill in this document. It is highly technical, and there's no way around it. It has to be highly technical. So if the technical person is not filling it in, at least all the data will have to be provided by that technical person. Okay, that just as an add-on. So then we come to grid connection. As I said earlier, this is a grid-tied system, and since we are in city of Zvorny here, we have a feed-in tariff, so we have feed-in with a bidirectional meter. Another option would be to have reverse power blocking. And yes, this installation is according to SANS 10.142-1, the wiring of premises and low voltage installations. This is a binding code in the binding wiring code in South Africa, and all systems on the low voltage side have to adhere to this. In the future, we are expecting a -1, -2, which specifically looks at the wiring of embedded generation systems on the low voltage side. And once that is publicly available, we will also add it as a requirement to this document. And the other required information here is that the system is installed according to NRS 097-2-3, which is the standard that defines the capabilities of the grid to take or the interconnection requirements of embedded generation systems to the grid. The next step is the commissioning. So you are asked to state the date of installation and the date of commissioning. Very simple. And then we come to probably the most difficult part, even though it's just a clicking exercise: electrical safety, fire safety, and lightning and voltage protections. So as you can see, all the questions here have a little star. So you have to click all of those, but please don't only click them, also read them and make sure that you confirm, or that your installation confirms with the requirements that are stated here. Because in the end, you as the installer will be liable, and if you don't stick to the standards and to the state of technology which is defined by the standards, you can be held liable. So DC installation protection class 2, cables are UV and waterproof. So all basically things that you would say, yes, of course it has to be there. But please, once again, make sure it really is. The same for fire safety, so provided there are firewalls or fire compartments, then of course you have to take them into consideration already during the planning, but also then during the installation. And a warning sign at the building grid connection point has to be installed stating that there is a PV system on that building. If there are any additional measures, of course, please feel free to state them here. Next up is lightning and voltage surge protection. So the first question is, has a lightning surge risk assessment been done according to the specific standard? We recommend to do it, but there are exemptions where you might not be required to do it. So if you did, please state yes. If not, no. Does the building have a lightning protection system? So in my case, the building has no lightning protection system, so I stated that. And so I also stated that no additional extra lightning protection necessary due to technical, legal, or contractual reasons. It's a small residential home, so there's no necessity. However, we recommend that equipotential bonding of mounting structure has been carried out for the mounting structure cross-section at least 6 square millimeters for copper or comparable, and that type 2 DC surge arresters are installed near the DC-AC inputs of the inverter. And yes, I followed that recommendation with this example and did that, provided the building has a lightning protection system. So in the commercial and industrial space, that will definitely be the case, but also with larger residential systems, I wouldn't be surprised if you will find exactly that. Then, of course, you have to incorporate that into your planning and into your installation, and follow the, well, we recommend to follow these rules down here. So, and the final aspect is wind loads. So again, wind loads have to be calculated according to SANS 10-160-3, the basis of structural design and actions for buildings and industrial structures. So this is a binding standard. If you don't adhere to it and anything happens to the building or the surroundings, then you can be held liable. Especially for electricians, this might sometimes be difficult, because you're not structural engineers, you're electricians or electrical engineers. So in case you don't feel comfortable, please consult a specialist, consult a structural engineer to give this specific input, because, as I said, you don't want to be held liable for this. If you did consult a specialist, then please state the names or the name of that specialist in these free text boxes here. And again, you will have to click and state that the anchoring and load application was carried out in accordance with the manufacturer, calculatory proofs, and so on, and that the roof penetration was carried out in accordance with technical standards and guidelines. What you don't want, of course, is that the roof starts leaking because of your work, and your customer will hold you liable for that. And then there's some general data on the house, so height of building, wind speed, wind load zone, and so on. So these are all data that you can simply take from your planning and installation. And if other measures regarding wind loads have been performed, please also state them down here. And that basically was the major part of the PV GreenCard. But there's another page here, which now is a huge clicking exercise. But again, you could just click it and the system would be fine with it. But what you do here is you state that you provided all those documents that are listed here to your customer. And we advise customers or your clients to check that all the documents have been made available to them, so that there is a full documentation of the system. And if you did that, then you can just click all the fields here. It is basically a good reminder also for you to have a complete documentation. However, there are a few non-binding. So for example, the structural engineering documents, it's only where applicable, and the yield on consumption analysis and the documentation of system monitoring. So if there's a system monitoring system, please also document it. And if you did a yield analysis with a software like PV Sol or PV Syst or any online tool, please also provide that to the customer and click it here. And once you did that, you can simply click on Submit Form, and then it will go to your client, and he will be able to check it. And if he's in agreement or agrees with it, and all the documents have been provided, then he will approve it, and then the actual PV GreenCard will be issued. Yeah, and that's basically how you fill the form and how you issue a PV GreenCard. And that leaves it with me, and I say thank you for listening and watching. Goodbye. $40, right?
Yeah. That was really good.
No, it wasn't.
Which parts didn't you like?
Several parts.
Specifically.
I don't know.
I like it. I think it's the right tone.